Have you ever stopped to think about how your favorite social media app or, a global streaming service can somehow handle millions of people all using it at the exact same time? Well, today, we are going to pull back the curtain on the incredible engineering that makes all of that possible.
The answer isn't some single magic bullet. Nope. It's a journey, really. It's about solving one problem after another, each time with a pretty brilliant engineering solution. And our journey, well, it starts with the smallest, most basic interaction you can have. You see, everything you do online, whether you're loading a web page or sending a quick message, it all starts with one simple, fundamental action: a single request. Just think of it like ordering a coffee. You're the client. And when you ask for a latte, that's your request. The barista, the person who actually makes your drink, they're the server. It's this simple back and forth that is the foundation for pretty much every single app you use. Okay, but how does your browser even know where to find that server? Well, every server has what's called an IP address, which is basically its phone number on the internet. But you don't type a string of numbers to visit a website, right? Of course not. That's because the domain name system, or DNS, does all the heavy lifting for you. It acts like the internet's giant phone book. And just like that, in a blink of an eye, your request finds its way to the right place. You type in a name you can remember, DNS translates it to a number the machine can understand, and your browser connects. This whole thing happens seamlessly, every single time you go online. Pretty cool.
All right, so now we hit our first big challenge. And it's a good problem to have: success. Suddenly, it's not one user, it's thousands, then millions, all sending requests. Your one little server is completely overwhelmed. So what do? You've really got two main choices. You can scale up, which means getting a bigger, beefier, more powerful server, kind of like trading your car in for a giant truck. Or you can scale out by just adding more servers, like adding more cars to a fleet. Now, scaling up is a quick fix, but it gets super expensive, and eventually you just can't get a bigger truck. Scaling out, on the other hand, is the real secret to massive global growth.
But wait, if you have a whole bunch of servers, how do requests know which one to go to? That's where a load balancer comes in. You can think of it like a traffic cop, standing in front of your servers, intelligently directing all the incoming requests across your whole fleet. And if one server happens to go down, the load balancer is smart enough to just redirect traffic to the healthy ones, keeping your app online, no problem. Great, so we've solved the traffic problem for our application servers, but all those users are creating and accessing a ton of data, and now our single database is the one struggling to keep up. This is our next major bottleneck. The first big decision here is what kind of database to even use. You have SQL databases, which are really structured, kind of like a spreadsheet. They're perfect for things that need rock-solid consistency, like your bank account. Then you have NoSQL databases. They're way more flexible, and they're designed for massive scale and data that changes all the time, like a social media feed. In reality, a lot of modern systems cleverly use a mix of both. But even with the right database, fetching data can get really slow as it grows. And let's be honest, a user waiting for their profile to load is a really bad experience. Luckily, our first line of defense is to just make those lookups faster. And we do this with something called indexing. You know the index at the back of a book? Instead of reading every single page to find a topic, you just look it up in the index and go right to the page. A database index does the exact same thing for your data. It lets the system find a user's record instantly without having to scan the entire massive table. But what if indexing isn't enough? Well, the next step is replication. Here, you have one main or primary database that handles all the new data coming in. Then you create multiple copies, or replicas, that only handle reading data. This spreads out all the read traffic across many machines, which dramatically improves performance. But what if we could avoid hitting the database altogether for the most common requests? Now, this is where it gets really clever. Accessing data from a computer's memory is literally thousands of times faster than getting it from a disk. A cache is just a layer of that super fast memory where we can store your most popular data. Here's how it works. The app first checks the cache. If the data's there, we call that a cache hit, boom, it's returned instantly. If it's not there, a cache miss, the app goes and gets it from the database like normal. But, and this is the crucial part, it stores a copy in the cache on its way back. This ensures that the next time anyone asks for that same data, it's served up in a flash.
Okay, so eventually your data can grow so large, we're talking terabytes, that you just can't store it on one machine. I don't care how powerful it is. The solution is called sharding. Think of it like breaking up a giant encyclopedia into individual volumes. You break up your huge database into smaller, more manageable pieces, called shards, and spread them across many, many servers. This lets you scale your storage almost infinitely. So at this point, our system is pretty robust, it's scalable, but now we need to make it fast for everyone on the entire planet. And we need an architecture that's actually easy for our engineering teams to maintain and update as we go. A huge cause of slowness online is just plain old physical distance. A CDN, or content delivery network, solves this by placing copies of your content, things like images and videos, on servers all around the world. So a user in India can watch a video that's technically hosted in California without any buffering because it's actually being served to them from a local server right there in Asia. Now, internally, how the code is organized also matters a ton. A lot of systems evolve from what's called a monolith, one giant, tangled codebase, into microservices. This just means breaking the application down into small, independent services. You'll have one for user profiles, one for payments, one for search, and so on. This is an absolute game changer for development teams because it lets them work on and scale their one part of the app without affecting the whole system. So how do all these little microservices talk to each other without causing complete chaos? Well, instead of calling each other directly, they often use message queues. A service can drop a message like, hey, a new video has been uploaded, it needs to be processed, into a queue. Then another service can pick up that job whenever it has the capacity. This decouples the whole system and prevents a sudden flood of uploads from grinding everything to a halt.
Okay, finally, let's zoom out to the guiding philosophies. These are the fundamental rules of the road, the trade-offs that engineers are constantly thinking about when they build these incredibly complex systems. These systems are all built on a foundation of core principles. For example, the CAP theorem forces you to make a choice. When something goes wrong, do you prioritize showing users the absolute latest data? That's consistency. Or do you prioritize just staying online, even if some data is a little out of date? That's availability. You can't always have both. Then there's rate limiting, which is like a bouncer at a club, preventing any single user from overwhelming the service with too many requests. And idempotency is a critical safety net. It just ensures that if you accidentally click Pay Now twice, you'll only get charged once. These are the rules that make a system truly reliable. And there you have it, from a single, simple request to a global distributed network that serves millions of users. Every step along the way is a deliberate solution to a very specific problem. These are the fundamental building blocks of the modern internet. And now you have the map of how it's done. So what will you build with it?